everyone, I hope you're doing well. This week we're going to be talking about freefall motion because freefall motion uses an equation that we're familiar with. It uses one type of quadratic equation. Freefall equations describe the height of an object at any time when it's in freefall, meaning the only force acting on it is gravity. It's important to note that freefall functions only describe the vertical up and down movement of an object at any time. Freefall equations create a graph in the shape of a parabola, an upside down parabola, because they're quadratic equations. For example, if I throw a ball straight up into the air, it reaches a maximum point and then eventually comes back down to the ground. If I were to plot the points of what height that ball is at every second and then graph those points, it would create a parabola that looks like that. Freefall equations are one type of standard form quadratic. Standard form quadratics are in the form y equals ax squared plus bx plus c. And your y and your x could be other letters. You'll see down here we have h and t, but it's important to note that a, b, and c are always going to be numbers, and the a value is always going to be -16 for a freefall equation that's in feet, which is what we'll be looking at. When you throw an object up into the air, its height can be modeled by this standard form quadratic equation. H equals -16 t squared plus the initial velocity times t plus the initial height. The h stands for the height at time t, and when we enter this in the calculator, we'll enter it as y equals at the beginning. -16, the a value, represents the force of gravity pulling the object down. So -16 always stays -16 at the beginning of the equation. Our t stands for time, and t is the same as x on the calculator. So if I were to enter this equation, it would say y equals, and I would have x's everywhere I see t. Example 1, a rocket is launched from a 5-foot launch pad at an initial upward velocity of 320 feet per second. Assuming the engine fails, the force of gravity eventually pulls the rocket back down to Earth. We need to underline the two important pieces of information, which are the 5-foot launch pad and the 320 feet per second. Those are the two numbers that are going in these blanks, but they're not necessarily going in that order. So we have to remember what goes in front of t here and what goes at the end. In front of t is the initial velocity, so in this case that's 320 feet per second. And in the last spot is always the initial height, so in this case, 5. Part B asks us to sketch a graph of the rocket's path using Desmos, and it wants us to include the initial takeoff, the maximum point, and the landing on the ground. So I need those 3 points to be in my window. Remember when you graph it to put y equals in front and to put x instead of t. Now when you first see the graph, it's going to look kind of like a vertical red line. You can zoom out to kind of see both of the x-intercepts, but we still can't see the maximum, the top of the parabola. So I need to increase my y max, and I can do that by going to this little tool in the top right corner and changing the highest y value underneath y-axis. I'm going to start with like 600. Now it looks like I can see the curve better, but I still can't see the maximum at the top. So I'm going to change that to 2000. Okay, so now I can see the maximum at the top. I'm going to click my 3 important points, the takeoff at 5 feet, the maximum or the vertex at the top, and where it lands and hits the ground. So I'm going to plot these 3 points on my sketch. 0, 5 would be about here. 10, 1605, the vertex, would be about here, slightly above 1600 line. And then where it lands, it was 20.016, 0, so that's right after 20. Your dots don't have to be in the perfect spot, especially on a graph with units this big, but then you can connect your 3 points with a smooth curve, an upside down parabola, and you want to make sure you don't go beyond the x-axis down here or beyond the y-axis over here. We don't go beyond the x-axis over here because we don't have objects going through the ground underneath 0. And we don't have the object starting before 0 for time because we don't have negative time. So part C asks us, using your equation, how high is the rocket after 3 seconds? I can do this 2 ways. I can do it with algebra, by hand, or I can confirm on the graph in Desmos. With algebra, I just want to plug in the 3 seconds for t in my equation because 3 seconds is a time. So I'm going to copy down the equation from before. And then I'm just going to replace those t's with parentheses 3. And at this point, you could put this into a regular scientific calculator, this expression right here. If you put this expression right into Google, it should calculate it for you. Let's try that. So we get 821. And because this is a word problem, I have to think about my units. It asked me how high, so it's talking about feet because all of the heights are in feet for this problem. Now I'm going to confirm this on Desmos by entering x equals 3 and seeing where that point is on the red graph where x is 3, and it looks like the y value there is 821. Part D asks, when does the rocket reach its maximum height? And in order to find this, what we really want to think about is how the maximum would be at the top of the parabola, and that would be the vertex. Well, we have a formula for getting the x value at the vertex. We can find the x value of whatever this point is, this vertex is, by using the axis of symmetry formula, which is x equals negative b divided by 2a. So I'm just going to look at the equation to get my b and my a values, and that's going to give me the x value of the vertex. Remember, this is in standard form, so the first number that comes in front of t squared is our a value. So negative 16 is our a, and 320 is our b value. 5 is our c, but notice we don't have a c value in the axis of symmetry formula. So I just need to plug in b and a. So I'm going to write x equals, instead of negative b, it's negative 320. And then I have a 2. I'm going to put parentheses so that I multiply 2 times a. And instead of a, I'm putting negative 16. Again, I'm going to plug this into Google as a scientific calculator and see what I get. So this comes out to 10. And if I'm thinking about my units, my x is the same as my t, remember, which is time. And if I was looking at it on the graph over here, remember the x-axis is the t's, the times. So I'm going to write 10 seconds. To confirm on the graph, I'm just going to click on the maximum, the vertex, and see that 10 is the x value or the t value at that point. So now part E wants to know what is the maximum height. We know when it reaches the maximum height is 10 seconds, but what is that number that it reaches? How many feet? So I'm just going to plug in my 10 seconds for t, just like before when it asks me after 3 seconds, how high is the rocket? I'm just plugging in 10 seconds now. And I'm going to enter this into a scientific calculator or Google, and it gives me, so it gave me 1,605, and that's going to be in feet because we calculated a height. When we look at the graph, we see that y value is 1605, so that confirms our answer. For this last question, we normally would show you how to do this with algebra using something called the quadratic formula and how to do it on Desmos, but we're actually only going to do it on Desmos this week. So anytime you see this question, how long does it take before it hits the ground? When you see that this week in your classwork, you are just going to use Desmos to answer this question. On Desmos, we're looking for when it hits the ground, so that's this last point where the rocket reaches 0 for height. And we want to look at the x value. We know 0 is the height because it reaches the ground, but we want the x value, the time, to tell us when that happens. So in this case, 20.016. So 20.016 seconds. So those are the different types of free fall questions that you'll see in your work for this week. Don't forget to be in touch and feel free definitely to reach out if you have any more questions. I know this is new material and that's a little bit tricky to learn just through video.